So welcome to this presentation of Edgecam Freeware and also tips and tricks. So throughout the freeware demonstration I'll also be placing in a smattering of did you know ideas, tips, tricks, silly mistakes maybe that users make during everyday usage of the software. Okay, so we're going to begin by doing some slot machining on this component, which you can see is held inside a trunnion style machine tool. We want to adopt the trachoidal method. Now we do have trachoidal inside Edgecam, but only in the roughing cycle. So a user expressed a preference for cutting hard aerospace type materials to get the best out of tool life to use a trachoidal type pattern. So you'll notice under the extras menu, which automatically gets installed once you install your freeware software, that the extras menu offers you trachoidal mill slot. So the spiral and the square toolpath style is just simply, as you would guess, the pattern of the toolpath. We need to just make some manual inputs on the width of the slot and obviously the fees and speeds. The add label number, the actual number is not important, although it may be a bit of a clue as to why we ask it. We ask it because we actually use a translate command within the PCI, and then I'll just place a depth in here and a traverse pitch. The traverse pitch is actually checked as well, so you'll notice here that it'll just warn me that I've gone too much for the pitch in respect to the tool diameter. So I'll just come back and temper that down a little bit to 3mm. So it'll just simply ask me where do you start and where do you stop. So if we go on to the beginning of this line, I've only drawn a line just for convenience sake more than anything. Now the end of the line. What you'll notice, it actually jumps back into design and places an arc. And this arc is actually being used covertly in conjunction with a profiling cycle. So the side of the arc line or arc entity is correct. We just right click, it throws us back into manufacturing, and it produces the trachoidal toolpath. Let's just slant the tool in there and play this back. So it's like an oscillating type tool pattern where the swarf is allowed to evacuate in a certain manner, as you can see here. And this is obviously evacuating swarf in a very specific manner. If I just expose the sequence instruction menu, what you'll notice is that it's used a profiling cycle. It moves it into position, then uses the profiling cycle, and that's why it asks for a label, so it knows what label number to use in conjunction with the profiling cycle. Let's just clear that and just do another. Just show you the other type of effect that you get with trachoidal mill slot. That's a square pattern. It's very much like a dog leg or a crabbing action, where it uses a square motion to cut the slot. This time I'll just digitize in the opposite manner, and you'll see how it crabs away using the pitch, going to the depth along that particular pattern. Let's just speed things up a little bit again. Okay, so you see that. So that's again exactly how this particular user wanted to cut that slot, and it was using the PCI macro that gave him that opportunity. I'll now move index. That's not a problem because I need to reposition myself into the front face. You can see that indexing across there, and obviously you just want to check it for consistency inside the tool, inside the machine simulator. So if I stand at the front of the machine tool and ask Edgecam to play, obviously we'll see now the square type trachoidal method being adopted. Very shortly we're going to come up to index, so I'll just move to the front of the component. You see the oscillation taking place. So we do an up and over index, but what you'll notice is that the tool itself has become detached from the spindle. This is a common mistake that we tend to come across, and users believe it's because they've incorrectly set up the kinematics of the machine tool, the CGD file. It's nothing to do with that. It's actually to do with the fact that the stock hasn't been set to secondary rotary axis. So it's a very common mistake, and it can save users many frustrating minutes or indeed hours when they're researching a problem. It's nothing to do with Code Wizard, it's just simply to do with the fact that they've not set the secondary rotary axis. And here we see the spindle is fine with the tool, but of course the stock is incorrect, fixturing is incorrect, and that's the same problem. So it can save many a frustrated couple of moments if we know that little problem, secondary rotary axis. So take it back to the simulator. Obviously all will be well here. You just swing round into the front again, and if I'm stood at the front of this trunnion type machine tool, you'll now notice how it's indexed away from me, so I can't actually see the component. So again, another little tip or trick to determine the position of the index inside the index command. You do have alternative solution, and what that will simply do is swing it into the opposite direction, take the second alternative CPL position, and that's why it actually creates a feedback message here, as you can see, about it has created a second CPL similar to the first CPL, which is just simply the alternative solution. And some users get a little bit confused by that. It kind of manifests itself that when they come back and edit the index command, they ask themselves, well, where's the alternative solution checkbox gone, and why do I have another mimic CPL, a twin CPL? That's just simply because Edgecam has now amended the original CPL and then kept a copy of the original CPL, called it face A.1. So that's perfectly normal, it's not an error. And if we see the simulation now, I'll speed it up inside the simulation as we stand at the front of this particular machine. We get a swing round, but we also, you may notice, we've got an error there as it just clipped the component. So I am getting the swing round in the correct position, and that's thanks to using the alternative solution functionality. But of course now I've got an error, and normally what you would have had to do is do a move rapid and make it safe. Of course we don't need to do that. And another little tip or trick is try using the safety clearance zone. If I push this up to say 200 or 300 millimeters, it will just pull that into a safe position for us. So again, people get stuck in their old habits, using a second rapid move to move it away and then to move it in. No need to do that. And also remember that you've got the alternative solution inside your index command as well. So that now gives us credence to start looking at these other slots. And in this particular case, we're going to use not trachoidal but zigzag. Now this is new to freeware, zigzag mill slot. This uses like a ramping motion. So if you just open up the command, you can see that it accommodates both wireframe and solid, and also roughing and finishing. So I've just populated this dialog area just to do a wireframe roughing pass. I'll go -20. The zigzag increment is critical. That's the amount it will ramp forward by, and this will just simply ask me to state the beginning of the slot, and then it'll ask me to state the end of the slot. Just come in here and just digitize the end of that slot there, and you'll see that you're getting a zigzag motion coming in. Okay. And of course what it's actually doing is, if I expose the instruction sequence menu, just a number of feed motions using your pitch increment, using the depth increment. So obviously imagine the user having to do that day in, day out, but do it manually. Obviously the solution, the answer, is to use and manipulate Edgecam's PCI template, PCI writing facility. The same function is also supported in a finishing command. So if we go again for zigzag mill slot, wireframe, but this time with finishing turned on, you do need to populate the XY feed rate, the offsets, and so on and so forth. So I'll just do that right now. Obviously put a speed in there, because you might legitimately want to have a different speed when finishing. Do need to be a little bit careful with the lead in, because the lead in does use, or rather this command does use, the profile cycle, so the lead in can't be too excessive, and it will actually error check that for us as well. If we look at the depth parameters again, we'll go -20 on the depth of the slot, and I can have, if I wish, a dissimilar finished profile depth, but I'm going to keep it the same here. So we're doing wireframe again, and this particular instance is going to ask me where is the slot to profile. So it's actually going to chain that outer segment, And that's a clue there. Obviously chain command implies it's going to be using a profiling cycle. And then again, where is the start of the slot and where is the end of the slot. And again, in this particular case, if I just expose the command, it's used a profiling cycle right at the end. So it's used the feed in, feed in, feed in, and then zigzag at the end. So you can see these just simple PCI templates being adopted. If we just finally look at the next command, or just use it on a solid, because we do have some a solid menu mentioned here. Solid, not finish pass. So again, this dialog area is quite plain. We'll just go to -20. This is just simply asking to go for the vertex of the solid. So in this center area there, this center area here. If we do it one more time for the finishing will actually be associative. Zigzag mill slot, zigzag mill slot, for solid, finishing the pass. Let's put just some values in here again. I'll keep that nice and low so I don't cause any errors with respect to lead in, lead out. We're going to -20, but the profile finishing is associative because we've gone for the solid option in this particular case. So again, it's a case of digitizing the profile, so now it's a solid feature that it will require, and then the usual where do I begin, so it's the vertex in the center of that cylinder, and then the end is over here. And let's just take that into the simulator just to show you everything all at once. So in conclusion, what we've seen in this particular demonstration is trachoidal and zigzag slot. We've seen a couple of useful functions to do with how we index a part. We've seen correcting the stock in the fixture using the secondary rotary axis, the alternative solution, and also the level command inside the index command. And here we see obviously the zigzag effect, and obviously the finishing off of the slot as well. Okay, so let's move on. In this particular case, the user has a solid model, and the solid model has to be chamfered, as you can see here. Now, if I look at you right hand elevation, you'll just get out a little bit better. So what I want to do in this particular case is chamfer, as we can see here, using a taper style cutter. I am aware that inside the profiling command we do have 3D profiling, but of course it's only on wireframe, so it means I have to build some wireframe design around my component. And of course that's not an issue. We just say solids, create me some geometry from the edges, individual curves, and I'm digitizing around the edges here. And of course the geometry that I'm producing is geometry that's going to eventually be offered up to the 3D profiling cycle. So let's just take that across into manufacture. Notice how I use the flyout menu to jump between design and manufacture rather than using an icon. It just tends to speed things up a little bit. And in a profiling command we say on a wireframe using 3D profile, I'll push the offset into negative. You can't go larger than the radius of the cutter. I will be warned about that. And then obviously just populating sizes that suit this particular machining condition. As I'm filling these in, obviously this makes a very good justification for a PCI, rather than have to remember all the fields in the dialog. Use it as a PCI, and it really emphasizes what we said in the first demonstration with review. So of course now I'm ready to offers me the ability to digitize the profile. And if I do a chain, I know it won't work because it's a 3D profile. So I would now have to stop on my tracks and have to turn this function on in preferences. So rather than breaking the user's train of thought, to do a 3D chain you can actually hold your control key down and then do a double left hand click. This will chain the item for you, so it prevents the user from having to stop, go to preferences, and then do the 3D chain command. And it's probably better that a user works with 3D chain not switched on, so the control command allows him to do that. Obviously I have to machine the partner, so I can do a drag drop with the control key held down, so that's our copying command, another little bit of a do you know, and we can just edit the command and chain the entities that are on this side. So control key is now depressed, chain, and of course we get our our particular profile, and that now satisfies the chamfering of that particular solid model. Let's just run it through into the simulator. Another little tip or trick, obviously we've got this on a pass machine tool over here. Normally a user would zoom into the area that he's interested in, and then when we say play, of course the stock and fixtures and so on and so forth come out of position. We have to furiously grab hold of the mouse and pull it back into position so we can see what's happening. So another tip or trick is that you can turn off machine simulation by pressing this icon here, machine simulation on, machine simulation off. So with machine simulation off, I'll just do a quick reset. It actually places the part in a position where the user doesn't have to grab hold of the mouse furiously and bring it into position. So that's just a little tip or trick, the machine simulation command. As you can see here, we've just satisfied the chamfering of that part using a wireframe function. Okay, so let's move on to another function, a global edit. Now this is a function that's been inside Edgecam for many years, but probably has been disregarded because of the instructions window or the instructions menu. Before we had the instructions window, we used to use the editing menus. I'll show you what I mean. We've got a component here, obviously plenty of toolpaths have been executed, 33 toolpaths. They all contain obviously fees and speeds, and now the user decides that he wants to change all the fees and speeds. Well, it is obviously possible to do that nowadays in Edgecam because we have our associative link inside the tool store. Whenever you pick a tool from Edgecam tool store, it can remain associative, but in this particular case it's an old file and the user maybe wasn't aware of it. We can obviously edit them by globally picking out every single command, editing and then changing the fees and speeds, but obviously that becomes very time consuming. So a nice little did you know is under the editing menu, which is the menu we all used to use before the instructions window was produced. We have a global function here. So with global now turned on, I can pick out all the commands. Edgecam presents me with a window now which encapsulates every common modifier within those commands. I just want to halve my fees and speeds. Just as another did you know, you can do -2 and do any type of BODMAS rule, maths rule on here. We can press Control equals again as another did you know in order to realize the value, and I'll just kill off any other parameters that I don't need. So when I now answer OK, Edgecam will go through those 33 CAM instructions, globally changing all those commands, and just check that's true. You can now see that in all those feeds and speeds in any of the commands that have all now been halved. So again, a very nice decent function. Just before we leave the file, when we know and understand that when we zoom in, zoom out, we're using the wheel on the mouse. Some users do ask us questions about, well, how do I reverse the motion of the mouse wheel? Maybe it acts against the CAD system that they're using. SolidWorks is a very good example here. Well, the answer to that one is obviously in the preferences area. You do have a function here called mouse wheel sensitivity. One little trick is some people put 1 inside there. Obviously 1 times 1 is nothing, so we don't get any zooming at all. So that's a bit of a trick that people could play on a colleague. But seriously, by putting 0.9 in there, we can actually reverse the way we zoom. So anything smaller than a whole value reverses the type of zoom that takes place inside Edgecam. And again, another little decent trick, tip or trick for saving users having to go into maybe the mouse settings. Let's have another look at an item here. Multiple continuouses and using surfaces and ruled surfaces in this particular case. We have obviously here a number of profiles that we need to place a surface over. We know that when we make ruled surfaces, we normally would employ a continuous entity, and we can make a continuous entity, that's not a problem. Continuous, and then chain, and chain the fourth item. But what this will do is it will produce 4 continuouses, and that really wasn't what I was after. I was after 4 individual continuouses. So I've just done an undo, and what we'll do is we'll now use a new freeware function, and in this particular case the freeware function is called create continuouses, and in this particular case it allows me to window the area. and then when I release, it's now done me my 4 individual continuouses, but all done inside one transaction, so a nice time saving there. I still need to create my ruled surface. The rules of ruled surface tell us that we need a second entity, so I can just simply draw a point, and again, not a lot of users tend to appreciate that you can use a point. In this particular case, the ruled surface is probably only being used for some patching on a solid model, so I can go between a point and the continuous in order to use a ruled surface. A practical example of something like this is what we see in the next example, where we don't have access to a solid model, where we can't really use a boundary. I want to box in these cutouts on either side of this component. I want to drive the cutter inside the V-shaped valley, so I need to patch in each of these cutouts. So a method and a way of doing that is obviously to use our continuous, to use our ruled surfaces, and this is where the create continuous command is extremely useful and beneficial. Again, I'll just window that area. It will do me my 4 continuouses, as we can see here, and then what I'm about to do is just create the second element of the ruled surface, which in this case is just a plain line, and I'll just simply go from here to there. You may notice that I took my cursor down to the bottom right hand corner then to switch between free and entity. And again, some users don't know that. They waste a couple of seconds just waiting for it to latch on, and okay, so that will draw the line for me. But again, I'm using my shortcut menu here, which again is another little tip or trick. Don't go reaching for the icon, use the shortcut menu. We could force the cursor to always go for an entity by clicking entity on the bottom right hand corner. Now I don't have to be too accurate with that digitize. Now I can go for my rule surface. So it's just a little bit of a time saving rule really. And then the rule surface again doesn't have to be precisely accurate in this particular case, but it certainly is a perfect solution to box in the sides of that particular component in order to drive a cutter along. So again, a number of tips and tricks in there, supported also with the freeware function. Another item that is close to my heart is the making of an edge loop feature. Obviously everybody uses edge loop features nowadays when we do 5-axis toolpaths, or indeed when we're just making a boundary. And because there's a lot of digitization involved in an edge loop feature, people can become frustrated if they've misdigitized. So in this particular case, if I just kind of demonstrate the scenario, we digitize, we go and do another 20 digitizes, then we finish, and unfortunately we've missed a little part of that edge. So to try and avoid the frustration, when you make an edge loop feature, it's always wise to maybe break the transaction. So just do a number of them, stop in your tracks, finish. Obviously you haven't completed the whole of the edge loop feature. I still need to go all the way around this part, but I can take a little break, double click obviously on the edge loop feature, ask it to edit the coordinate input, and now what I can do is begin to start moving my way around the rest of the part. And here's another little tip or trick. Obviously I need to rotate the part now around to get to my next area. And obviously when I rotate, the part is free to rotate in all X, Y, Z axis. If I hold down my X cursor, my X on the keyboard, you can see now it very convenient for me rotates in only one particular direction. So it enables me now to digitize this a lot more easier. Hold down that X key and roll again. So X, Y, Z depressed on the keyboard during a rotate command allows us to have a little bit more manipulation over how Edgecam rotates. And of course in this case we can take another little break, edit the edge loop feature, and go on again a little bit more. So it saves you having to do, say, maybe 20 digitizes. You get to the 18th one, make a mistake, and have to start all over again. Just keep on editing the edge loop feature. Another item that I'd like to demonstrate to you is align body. The align body command that we have in milling and also in turning. So in this particular case I've exaggerated the CPL marker, and what I wish to do is to feature find this hole. I assume that this face is perpendicular to this hole, and obviously what we'll find that that's not the case. But let's continue. Align body for milling. I digitize this face. It's now lined up, and I can maybe swing it round, and then maybe towards the end make the vertex the center. And then we have the assumption now that this will feature find, because we are assuming that the face that I'm indicating here, the hole, is perpendicular to the face, and of course we'll find out that it's not. I just do my feature finding, just ask it to find a hole in this particular case. You'll notice it doesn't find the hole, and upon closer investigation we'll notice that the hole isn't perpendicular to the face. And one way of knowing that and pointing out to users is that when you rest the cursor on the face, press V on the keyboard, the normal value is actually an indication of the position of that face in respect to z-axis. And we look at the z normal, it is at 1. It is a factor to the z-axis. It should either be 1 or 0. Anything in between indicates it's at an angle. If we go to prove that, if we go to the face, we can notice here that the z is 0.985. It's not a whole number. It's not a factor to the z-axis. So clearly that's why we have an issue here. It's not true to the face. So I'll just do an undo and we reload the part in the position it was originally. When you do an align body for milling, did you know that you can digitize the cylinder? It doesn't have to be a flat face. I think a lot of users are under the assumption that it has to be a flat face. No, it doesn't. As we can see here, we can pick a cylindrical face, and now I can just align that into center, and then I can just do my feature finding. And what we'll notice now is that we have the feature. And just in case you couldn't quite understand what I was talking about in respect to the position of this part, you can clearly see that it's not and was never true to the face. So align body for milling, you can digitize a cylindrical face. Another little item is to do with the tool reach inside Edgecam Tool Store. We understand and know that there is an influence over the tool reach. That's to do with the offset amount. Well, this is a typical symptom. We're furiously testing a part, we're simulating, we take it into simulator, we discover that we have, unfortunately, a collision. And of course this collision is being caused by the tool is not, there we go, we can see the clash now. We can see that this tool needs to be pulled further out. And of course that is quite simple and quite straightforward and normal inside Edgecam. If we look at this particular tool, we understand and we should know that there are rules guiding us in respect to the overall reach of the component, the reach and the offset, and obviously the ZXY gauge. It doesn't actually influence Edgecam at all if I place a value in there. It doesn't pull it any further out. It's obviously to do with the offset setting that we have inside Edgecam. But one way of learning the value, it's a bit of a cheap and cheerful way of doing it, is that if you press Edit Graphic Definition, which was the way we used to draw and still do use wireframe drawings with Tool Store graphics. Lots of people now will be using solid models. But even though I have used a solid model here, when I do the Edit Graphic Definition, what we'll see, and again just for the sake of the screen I'm going to highlight all this data here. What we'll see in this particular case is that we see the outline of the tool. I can place my cursor anywhere on the part, V on the keyboard for verification. Now I can physically draw, measure, verify the overall reach, and sometimes it saves users having to do a number of calculations. So it's just a really nice, cheap and cheerful way of checking a tool reach, tool stick out, if you will. Okay, so we'll move on a little bit further. We still obviously have and are using DXF IGs files, and obviously CAD interpretability of Edgecam is always has been and perceived as one of our strengths. If we load in an IGs file, as we can see here, we see, let's bring in all the parts. That's generally accepted. Bring the part in, but of course users will still be suffering from poor IGs files, as we can see in this particular case. Obviously that would be neither use nor ornament to a user. For those using Part Modeler, some people seem to be not aware of the fact that they can instantly clean and heal it, not by the clean and heal command, but by simply saying load as the parasolid body. So when you bring the parasolid body in, it actually in the background heals it, and obviously gives us a solid body. Solid bodies are probably and arguably better to work with, because now we can feature find it, use edge loop features, and indeed maybe use strategy manager on it. So if I'm just saying load as parasolid body, you'll notice how we've cured our problem. And we're still keeping on the theme of using non-solid files inside Edgecam. If we bring in this DXF file, this is actually a customer file, and it's actually a boilerplate. And again, just for the sake of everybody seeing this, I'm just going to change the colour, apply to all, and window everything. You'll notice how I'm windowing everything. You don't have to actually window it. You can do Control A on the keyboard. That's another little tip or trick. Control A on the keyboard, it just means select all, and I'm just going to change the colour here so everybody can see that. Yeah, what I've got here is a number of many different hole sensors that needs to be drilled out. In the license that the customer was buying, he didn't have the group hole option inside drill cycle, so it would be nice and convenient if all these were dropped into their own layer and placed in a group. That's actually possible by using, again, another extra command called group holes. Group holes by diameter. I just window all the holes, and it will create an Edgecam group, as we can see. So this will make it very convenient when we do the drill cycle. And not only does it create the group, it will also, if I just refresh my menu, it will also create layers of each of the holes. So we can do a show only on each of these layers, and begin to recognize and realize our groups. So lots of time saving created there due to using the group hole command. Okay, so finally, this is one that's tripped me up a couple of times. We bring my solid part in, working on this solid part. We know that Edgecam is associative to the solid part, and of course we can do that by checking the file path of the solid model. Again, a couple of tips and tricks coming up here. You'll notice at the moment it says 1 of 5 entities. Sometimes it says 1 of 50, depends on which way, how many entities are present on the cursor. Lots of people will tab, and that goes forward with the motion of tabbing. But did you know you can hold down the shift key and do tab, and that will reverse you? So rather than having to go 1 of 20 and then the 19th and the 18th, if you just do a shift tab, it takes you back. So that will save you having to do a lot of tabbing. In this particular case, if I press V on the keyboard, it's telling me where that file came from. Okay, if I go to the file and just make an arbitrary change, let's maybe just take that out there, just do a save as we normally would do. We go back to Edgecam, we fully expect a message telling us that it's been changed. Of course, we don't see the message, and then we might scratch our heads and say, well, let's just try that again. Let's just take out another design change here, save it again, and back into Edgecam. Oh, we don't seem to have this message. And again, it would actually make us query: is there a bug in the system? Have I not loaded something correctly? Is there a fault on the installation? The simple answer is actually hiding under the preferences area. Under the solids function, you do have the option to say, don't show me the change notification. And why would you want to do that? Because lots of users may be doing experimental parts where they want to deliberately work on the original model and not the change model. So just with that checkbox there, you'll now notice that the messages start coming through. So that's one that's caught me out, I must admit. Just a simple command under the options menu with preferences. Make sure that you've got your change notification on. Okay, so that finally concludes the presentation. Hope you've enjoyed it. Do try to download the freeware menu. It's available on the website, and I hope you've enjoyed tips and tricks, and that's all for me. Thank you very much for your attendance, and thank you.